If anybody want to ask something, yes, please. Please don't hesitate. If you anything is not clear, I can repeat the steps. I can do it again. Because once you learn SPSS, then data analysis will become very easy. Because there are many techniques, many things are there which you can do. Yes, please. So I don't think there is any question. Let me start with this session. Can you see the screen again? Yes, please. Is this visible? Anybody?
Yes, sir.
Yeah, okay. So I have explained you that how to enter the data in SPSS, how to assign labels, how to give the variable name, all these things we have discussed. Now, next part which I would like to discuss is about that how to select cases. For example, if somebody may be interested to look at that I want to select only those people whose score is more than or equal to 60 or more than 60, right? That who are the brilliant students. Then this data contains all the categories, less than or equal to 30, 30 to 60. But I am interested in a particular category. So those students whose marks is more than 60. Then how to select that category? So there is a option here. Go to data. Go to data. In data, there is an option, second last option, select cases. Right? Go to select cases, and in select cases, there are certain conditions. So you can stretch. For example, if it is, let's say sometimes it appear here and you are unable to see the variable, then you cannot stretch it from here. But if you place your cursor at the top, at the border, then you can move it anywhere so that you can see the variables. If it is appearing here, you can just stretch it. And if it is still not, then you can stretch it here also. I mean, you can see a very complete picture. That's in your hand for adjustment. Okay. Now it says select cases if certain condition is satisfied. Let's say I choose this condition. So it will read like this. Select cases if condition is satisfied. What is that condition? If, let us say, score code. If score code is equal to, because greater than 60 is 3, is equal to 3. So this is how it will do. Select cases if score code is equal to 3. Select cases if score code is equal to 3. Press continue, press OK, and you come back to the data and you will see that those cases which are greater than 60, they are selected. You see, in front of it is written selected, selected. And those who are not selected, they are struck off. So first is struck off, second is struck off, third, because they all does not belong to greater than 60. They all belong to either less than or equal to 30 or 30 to 60. Similarly on this side. So now what is the advantage? Advantage is if I give any command, let's say I want to compute mean score, I want to compute how many males are there. So it will give the analysis only for those cases more than 60. There is no need to split file. In Excel, this is usually we do. If I want to make inference about male and female, then I make two files, one male for separate and female for separate. But here there is a flexibility in SPSS, and that flexibility says that there is no need to make a separate file. You just select the cases, give any command, and it will run over only those cases which are being selected. Hopefully you follow what I'm trying to say, right? Let's say I want to select next time, suppose, let's say those who are between 30 to 60. Then again go to transform, data, then select cases, and if change this to 2, make this 2. And if you make this 2, you will see another picture where all those which are less than 30 to 60, they are selected, and rest of them are not selected. That you can easily see, right? Now if I give any command, so command will run only for those cases which are between 30 to 60, rest of the things will not be evaluated. Right? Now, suppose I want to select all the cases back again. Then what to do? Again go to data, select cases, and there is an option here. Select all the cases again. Just press this. Select all the cases again, press OK, and then you come back and you will see that all the cases have been selected again, and then you can remove this filter. You can remove this filter. Now the entire data is intact again. So this is called selecting cases. If I want to select only male, then you can go to data, go to select cases, take this gender is equal to 1. Gender is equal to 1 means only male data will be selected. Okay. So this is how you can go for these select cases. But sometimes I want to do analysis for male and female simultaneously. Now, if I want to, let's say first for male analysis, then for female analysis. Now, if I use the if condition, then I cannot put 1 or 2 because I want to select both of them, but separately. That first analysis will be carried out for male and then carried out for female. In that case, there is another option, and that option is basically called splitting of the file. You can split file. So where is that option? Go to data, go to split file option, third last, and in split file, let's say split file and organize output by groups. Organize output by groups, let's say organize output by gender. So groups based on gender. Groups based on gender. And then press OK. And then you can see, if you go, otherwise this symbol always appear, Unicode on. But now this will change and it will say the split file is on. You see, split by gender is on. It says split by gender is on. Right? So what it has does actually, it has made 2 files. You cannot see those files, but from here you can see that males are separate now, females are separate now. Okay. Now, if you give any command, let's say I want to compute mean score or standard deviation or quartiles or percentiles or deciles, whatever I want to do. So first of all, male data will be evaluated, and after that followed by the female data, because your split file is on by gender. So that is the idea of splitting the file. Hopefully these things are clear to you. The next important point in SPSS is that if I want to make certain transformations, let's say I want to make log transformation of this score. Log transformation of this score, you can do that easily. So go to transform, and there is an option which is called compute variable. Compute variable. So if you go to compute variable and take your score to this side, right? Now it is asking, no, let me do it again, because I want to take a log of this, log of score. So first of all, select which kind of function log is. So everybody knows that log is an arithmetic function. So all functions are given here. Arithmetic functions, date functions, date creations, all these are given here. But let me select arithmetic. Then all the arithmetic functions will appear in this box. Click here. Now it says all arithmetic functions are here. Absolute value, sine inverse, tangent inverse, cos, exponential, log to the base 10, log, natural log, mod value, random, and so on. Let's say I want to take log of this variable. What it will do, the entire description will appear. That it will result, it will give you log to the base 10 of the given number. Log to the base 10 of the given variable, basically. So then there is an option that you shift this to this side. So you can shift here. Now it is asking you want to take log to the base 10 of which variable. So let's say score variable, in which we are interested, because log has to be taken only for continuous type of variable. I cannot take log of male and female. I cannot take log of score code. They are categorical variables. So take the score. So log to the base 10 of score. Now still OK is not appearing. Why OK is not appearing? Because it is asking where do you want to store this? It will be stored here next to this column which is vacant. So here I have to give the variable name. So let me give this as log score. So SPSS will generate a variable which will appear here. Name will be log score, and that will give you log to the base 10 of all these values. This is what the entire command is. Hopefully able to understand. Press OK, and now the analysis has been done and you are getting. So log of 12, log to the base 10 of 12 is 1.08. Log 66 is 1.82. Log 87 is 1.94, and so on. So it has computed all the log values. Right? Similarly, you can take, you can take a difference, you can multiply. Let's say I want to multiply these two columns. Right? You can multiply, although it doesn't have any meaning, but you go to, let's say, transform, go to compute, and here I am simply writing multiply. And which columns I want to multiply? You feed your expression. Let's say score code and log score. The score code multiply, this is acting as a calculator now. Multiply with score code, multiply with log score. So they will be, both of them will be multiply, and another variable name called multi will be generated here. That will appear here. So what it will give you multiplication of 1.08 with 1. That will appear same, 1.82 with 3. So it will be 4 point something. You can check. Press OK, and now it has done the calculations, and now you can see 1.82 multiplied by 3 is 5.46 this. So you can do any type of calculations here. It is just, where is the command? Transform, compute variable, and this is acting as a calculator. You can write minus here, then you can get right here subtract, and another variable will be generated that will give you difference. Press OK, and now you will get the difference. So you are getting the difference. Hopefully these things are clear to you, right? So if you don't require this variable, clear. If you don't require this variable, clear. If you don't require this variable, clear. So I have shown you how to split file, how to select cases, how to make transformations. Now, we will move on to our next part, which is called how to import data from Excel file to SPSS. Very important, because most of the people, they enter data in Excel. And now we will import some, we will take some Excel file and import that file into SPSS. Right? Before I start with the analysis. Yes, please. Any question? Yeah, if you have any question, please ask. If somebody is having some question, please, most welcome. Yes, please.
No,
Or, okay, all right. So now let's go through. I'm just closing this file. That's no one. Just close this file and close this file also. Now, let me show you some as this file. Let's suppose this is an Excel file on my desktop, and it is file name is test1. I'll show you the file first. So this is your file. So it has in the first row the headings: mutation, age, locality, sex, religion. And then if you scroll down, you can see number of observations. It is going up to 71. So obviously observations are not 71, it is 70. Why? Because first is a variable name. You will not have to count the first row because it's a variable name. So there are 70 observations. Now because in Excel, this name is test1, but in Excel, their data may be in sheet 2, data may be in sheet 3 also. Please remember, SPSS will import only one sheet at a time, whichever you select. So if you are selecting the sheet number 1, that is test 1, it will be, this data will come to SPSS. If, let's see, is there anything in sheet 2? Yes, sheet 2 also has data. So if you want to select this, only 20 observations will get selected. And sheet 3 doesn't have. Okay. Now, there are few important points before importing the data into SPSS. You can write down, please. My request is you can write down. Number 1. Always write down the variable names in small letters. Always write down the variable names in small letters. I have used the small letters. Location, small letters. Age, locality, sex, religion, or they are small letters. So always use small letters for variable name. Number 1. Number 2. Do not use any special character in variable name. Do not use any special character in variable name. What are these special characters? Special characters are percentage, ampersand sign, hash, dash, right? At the rate. All these dollar sign, etc. They are not allowed in the variable name. SPSS won't recognize. So variable names should not involve any special characters. That is number 2. Number 3. Variable name should not be more than 8 to 10 characters. Sometimes in new packages, I mean SPSS version 24, 25, they are also taking 12, 50, up to 15, but there may be sometimes compatibility issue. So make it a habit to write down the variable name as small as possible. 8 to 10 characters, maybe maximum up to 12 characters. Right? So I cannot give the variable name religion of the people. I'll simply write religion, one word. Right? I cannot write sex of the baby. I simply write sex. Or locality of the people. No. Simply locality, mutation, age. You follow my point, right? So always use one word for the variable name. Of course, you can use underscore. Underscore is allowed. Just like score code I want to write down. So you can give variable name as score underscore code. That can be written. That is acceptable. Next important point, which is very important. Your variable name, any of the variable name, should not start with numeric value. It should not start with the numeric value. For example, if you have age, say 40 years of people, then somebody may give the variable name as, say, 40 age, right? That this data is representing all those people who are having 40 years of age. But this variable name is not acceptable by SPSS. Why? Why it is not acceptable? Because it starts with the numeric value. Of course, you can write age 40. Age 40 is acceptable. Age 40 is acceptable, but not 40 age. Right? So variable name should not have any numeric value in the beginning. In the end, no problem. Or I can write 40 underscore age underscore 40. That is allowed. No, not a problem. Right? So with these conventions, so let me just mark here. I close this file and this is on the desktop. Remember its name. Its name is test1. We will import this file into SPSS. So I will import this file, closing the file. First of all, close the file. So this is test1. We will import this file into SPSS. Okay. Open SPSS again. Just wait. It will take 30-40 seconds. It's opening up. Press cancel. And then go to file. go to open. See, these are the steps. Let me just repeat. File, open, data, and give the path name. It is on the desktop. Now it is not showing that file which was test1. The reason is because our file of the type is SAV. SAV means it is showing only those files which are saved in SPSS or folders which contains SPSS files. So all these are SPSS files on the desktop. Okay. But our is Excel file, so change the file type. Your file type is Excel. This is Excel. Now the test1, that file is appearing. Right? So click on to this test1. Automatically the name will appear here. And now your job is almost over. Simply press OK. Simply press open, sorry. Press open. Now it will ask you one question. And here is your question. What is the question? Just broad and read this question. It says, read variable names from the first row of the data. By default, this option is on. Now, if you remember in Excel file, there was age, mutation, locality. That was the variable names in the first row. So automatically your variable name will also be imported along with the data. But in Excel, you can enter the data even without variable name. You can write under A, you can write under B, you can write under C, you can write under D. Again, the data will be imported. Data will be imported from Excel to SPSS. But since the variable name was not there, so SPSS will assign its own name. It will give you variable 401 to the first variable, variable 402 to the second variable, and so on. So it will continue like that. So, but this default option is there. And then, as I mentioned that there could be different sheets in Excel, but SPSS will import only one sheet at a time. So since this is a test one sheet, but if you want to import sheet number 2, you can write sheet number 2, then the data corresponding to sheet number 2 will be imported, right? So here ours is sheet number 1. And simply press OK and your data will appear here. Press OK and here is your data. It's coming up, just wait. Yeah. So that is here. Now you can see our first variable was mutation, next variable was age, then variable locality, then sex, then religion. So all these variables are here. And how many observations were there? If you remember, we have 70 observations. All of them we have been able to import. So this data from Excel to SPSS is very simple steps. Go to file, let me just repeat, go to file, go to open, go to data, and in data give the proper name, and then go to the Excel, import that file. If I want to import this file, the second one, it will be imported. The name will appear, press open, and then it will ask you that question, and simply then, after going through all these steps, you will get your file imported into SPSS. Yes, please. Any question? Up to this, if you have any question, all the basics of SPSS I have covered now. If you have any question, you can ask me. Yes, please. Now I will start with the analysis part, how to do analysis. But before that, if you have any question, you are most welcome to ask.
No, sir.
No question? Yeah, no question. Is this okay?
Yes, sir.
Good, very good. So I think very, very intelligent people are here who are listening to me.
No, sir,
तभी मुझे
well.
Pardon?
You are explaining very well.
Oh, thank you very much. चलिए, मेरे ख्याल से थक जाते हैं आप लोग, तो थोड़ा सा एक शेर सुना देता हूँ आपको. अभी शेर सुना दिया जाए. आपको हिंदी समझ में आता है?
Yes, sir. Yes.
अच्छा, हिंदी समझ में आता है. चलिए, आप शेर है कि आप सब लोगों से आज मुलाकात हो गई, तो उसी के ऊपर एक शेर है कि खूबसूरत सा एक पल खूबसूरत सा एक पल किस्सा बन जाता है, खूबसूरत सा एक पल किस्सा बन जाता है, ना जाने कौन कहां जिंदगी का हिस्सा बन जाता है। कुछ खास लोग यानी आपकी तरह कुछ खास लोग मिलते हैं जिंदगी में इस तरह, जिनसे ना कभी बिछड़ने वाला रिश्ता बन जाता है। सो यू आर वन ऑफ देम।
बहुत अच्छे है, बहुत अच्छे, बहुत अच्छे।
जी।
थैंक यू सर।
तो मेहनत करना इंसान की फितरत है, उसको मेहनत करते रहना चाहिए। और जिंदगी में आगे बढ़ने के लिए दो चीजें बहुत जरूरी होती हैं। एक को बोलते हैं इंसान की सोच और दूसरा बोलते हैं उसकी डायरेक्शन। अगर आपकी सोच कितनी भी अच्छी हो, अगर डायरेक्शन सही नहीं है तो आप कहीं नहीं पहुंचेंगे, राइट। और अगर आपकी सोच भी अच्छी है और डायरेक्शन भी सही है तो आप मंजिल को जरूर हासिल करेंगे। इसीलिए किसी ने कहा है कि सोच को बदलो सितारे बदल जाएंगे, सोच को बदलो सितारे बदल जाएंगे, नजर को बदलो नजारे बदल जाएंगे, कश्तियों को बदलने की जरूरत नहीं, दिशा को बदलो किनारे बदल जाएंगे। सिर्फ डायरेक्शन चेंज करने की जरूरत होती है एंड यू विल बी समवेयर एल्स। जी, बात समझ में आई?
बहुत खूब सर।
यस सर, बहुत कुछ।
मैं सिर्फ आज आपको यहाँ पे डायरेक्शन ही दे रहा हूं। और मेरा अगर किसी को भी अभी लगता है कि अभी भी कुछ समझ नहीं आया, तो मैं अभी आपके सामने एक यहाँ पे गूगल पे मैं अपना वीडियो बता देता हूं। मेरा वीडियो है यूट्यूब पे पड़ा हुआ, आप यहाँ पे डालिए स्टैटिस्टिकल टेक्निक्स। कैन यू सी द स्क्रीन नाउ?
यस सर।
Statistical techniques using SPSS by Suresh K. Sharma. By Suresh K. Sharma. And कुछ भी लिखने की जरूरत नहीं है and you will see. Okay, ये आ गया statistical techniques using SPSS by Suresh K. Sharma. So this is 1 hour 48 minutes video, and you can listen to this video carefully, right? And you can learn from here that how to enter data in SPSS, how to carry out correlation regression. Everything is given here, so you can go through this video. If you are still facing some difficulty in analysis of data, I think that will help you. Will that be okay?
Yes sir.
Yes sir.
All right.
Actually, when we'll be practicing, then it will be actually beneficial for us to see the video again.
Yeah, you can see the video and work on that, right? And just play the video and then pause and learn and you try, then I think that will be better. Because in one go it is very difficult to understand the things, I can very well imagine, right? Okay, now the first part, everything is over. If you still have any question, any query, I'm again giving you 1 or 2 minutes. Otherwise, I'll move on to the analysis part now. Yes, please. Any question? I will be happy if you ask some questions. Ji.
Yes, sir. Actually, I just I knew that the SPSS meaning full form of SPSS is Statistical Package for Social Sciences.
This was the name given in 1969 when the package was designed. SPSS, Statistical Package for Social Sciences. Then what happens? Only people from social sciences, they started using this package. Then immediately they realized their mistake. Then its name was changed to SPSS, and that name was given was Statistical Product and Service Solutions. That is the real name of SPSS. Statistical Product and Service Solutions. That was the name given that time, and it went for years together till 2009. In 2009, IBM has procured this entire software, and now they have given the name IBM SPSS Statistics software. That is the name that has been now everybody knows after 2009. So that is the history I am telling you. Any other question?
Thank you for the clarification.
Yeah, any other question?
Sir, one question.
Yeah, please.
Hello.
Yeah, please.
Sir,
when I'm giving some comments, the results comes selected, not selected, or high, moderate, low, etc. And the number of observations are almost 500 or 1000. But how can I get the number of high or moderate or low?
You have
It
to
is already
select.
showing high, moderate, low, etc. But I just want to know how can I get the number of high?
That, yeah, I'm just going for the analysis now. You will come to know. I'll just go for the analysis, and you will come to know how to get all this. How many moderate cases are there? How many? You want to count that, no?
Yes, yes, yes,
Yeah,
yes,
yeah.
yes.
We'll do the analysis. Just
Okay,
wait.
okay, okay,
Yeah.
sir. Okay, okay,
Okay.
sir. Thank you.
Any other question? So should I proceed for analysis? Okay. Now I will proceed for analysis. I have already created some data sets. So just to save time, let me open one or two data sets first of all, and then I'll give you the demonstration. Okay. Just wait, file is opening. Yeah. So one of the file is here. It is having three variables: age, along with that you have gender, that some of them are male, some of them are female, and then age code. Just like score code, we have age code. So I can check from here. First of all, values, one is for male and two is for female. That I know. And age has been divided into certain codes. Let's see how many codes. So it says age has been divided into 1, 2, 3, 4, 6 codes. So those people who are between 10 to 19, given code as 1, 20 to 29, given code as 2, and right up to 62. So age has been divided into 6 different codes. Right? Hopefully the data is clear to you that there are three variables. One is age, another is along with that gender, and age has been divided into 6 different categories. Those who are between the age of 10 to 19, then 20 to 29, 30 to 39, 50 to 59, and 60 to 69, 6 codes. Now, most of the time we are involved in counting, as the gentleman was asking, that I need to count, right? How to count once you have the categories? Then how to count is very simple. So here are the steps. Please follow. Go to analysis, go to descriptives, and in descriptives go to frequencies. And if you click on to frequencies, frequencies are generally computed for categorical variable. Let me just repeat, frequencies are computed for categorical variable. Frequency means counting. So I want to count gender. I also want to count down age code categories. And it says display frequency table. Display frequency table. Simply press OK and you will get the counting of the numbers. Here is your answer. So here is your answer. It says 169 observations. No observation is missing. So how many males are there in your data? 91. How many females? 78. Total is 91 plus 78, 169. This is the percentage. Then in age code also you can see how many people are between age groups 10 to 19. Only 4. Maximum people, they belong to which age group? Your answer is 20 to 29, 66 people. Next category which is having maximum number of people is 30 to 39, 47 people. Next 36 people, 12 and 4. So if you count the overall, again it will come back to 169. So this is the distribution in different categories of age. And this is the percentage in different categories of age. For example, maximum people, they belong to this, almost 40%, 39.1%. So approximately 39% of the people, they belong to this category, 20 to 29. 47 or 28% they belong to this, and so on. Then you must be wondering, there are two percentages. One is called percentage, another is called valid percentage. And they are same basically. They are same. Why they are same? They are same because there is no missing value in our data. There is no missing value in our data. If our data has some missing value, then you should not look at the percentage. Then you must look at the valid percentage. Then these two will differ. You must look at the valid percentage, right? Because let's say out of 100 values, if 2 values are missing, then the valid percentage will come out of the 98 values. 98 values. So valid percentage in that case you have to see. Then there is one more column that is called cumulative percentage. Cumulative percentage is useful in order to see how many people are below certain age group. For example, if you ask me this question, in your entire data, how many people are below the age of 39 or equal to the age of 39? So this is 39 cutoff. So I'll answer from the cumulative that 69.2% of the people are below the age of 39 or equal to the age of 39. So they are below 39, right? So generally younger people are almost 69.2%, right? So similarly, if somebody asks how many people are below 59 or equal to 59, 97.6. If somebody asks you how many people are below 29, 41.4%, right? Only few people are below 19 years of age. That is only 2.4%. So you can answer so many questions from here. So that is the advantage of computing the cumulative percentage.
Excuse me, sir.
Yes, please.
Actually, the valid percent, can you please explain that again? It was not clear.
Yeah,
Valid
valid.
percent.
See, here the percentage and valid percent, they are same values. Why they are same? Why they are same? Because there is no missing value in our data. There is no missing 0. Can you see the missing 0?
Yes, sir.
So if there would, suppose there are 2-3 values which are not filled up, they are missing, then in that case, this percentage and valid percentage will differ. Then which one to choose? In that case, if there are missing values, you must look for the valid percentage column, not for the percentage column. You follow my point?
Yes, sir. Yes, sir.
Yeah, that is the idea. So if there are missing values in your data, you must look at the valid percentage rather than percentage. Otherwise, both the columns will give you same if there are no missing values. Very good. Somebody has asked question at least. Any other question? Any other question? All right. Okay, let's do some other kind of stuff. So we able to know how to do the counting. Somebody was asking me just. So I think you are clear now how to do the counting. Yes, please. Somebody has asked
Yes, sir,
me.
got it.
Okay, very good. Now please mute yourself. Okay. Now let's go for some other kind of analysis. Go to analysis and go to descriptive statistics again. Again go to frequencies. And if you go to frequencies, now let me take this sex and age code outside. You can remove any variable and take this age here. The age is a continuous variable. And I will not have to make a frequency table for age because age is this variable. Otherwise, it will give you a very large frequency table. How many times 18 is appearing? Maybe one time. How many times 22 is appearing? Maybe one time. How many times 24 is appearing? Maybe 2 times. So it doesn't make any sense. So please remember, frequencies are to be computed only for categorical type of variables. So I have to switch off this option. So if you switch off this option, just click here. It is giving you a warning that you have switched off this option. No problem. I have switched off this option. Then what I want to compute? I want to compute mean age, median age, mod value, skewness, kurtosis, percentile, decile, whatever I want, you put under this statistics. What you want. To go to statistics, let's say I am interested to compute mean, median, mod, standard deviation, variance, minimum value, maximum value, range, skewness, kurtosis, quartiles. You can compute different percentiles also. Let's say I'm interested to look at 23rd percentile of the data. I'm interested to look at 78th percentile of the data. And maybe you are interested to look at 95th percentile of the data. So all these will be computed in one go. And how much time it will take? Fraction of seconds. Press continue here. Press OK, and the result is outside. So here is the result. You see. So this is the result. 169 observation. No observation is missing. your mean age is 34.30. That is the mean age of your entire data of age. Median is 31, mod is 26, standard deviation is 10.328. If you square 10.328, you will get variance. Square of the standard deviation will be, you can see, if you square 10.3, you will get 106.6. Skewness, this is the value of beta 1. Now, beta 1 value is 0.698. 0.698, this is the value of beta 1. And if you remember, if beta 1 is 0.698 is positive or negative? Yes, please. 0.698 is positive or negative?
Positive.
Positive. So what should be the interpretation? Is it positively skewed or negatively skewed?
Positively skewed.
Positively skewed, because value is positive, so your data is positively skewed. But I have also explained you important factor that if beta 1 is 0, then it is symmetrical. You remember that? If beta 1 is 0, then it is symmetrical. And here you can see
Yeah.
0.698. 0.698 is close to 0. 0.6 is very close to 0. So your interpretation will be that it is slightly positively skewed. Interpretation will be slightly positively skewed. Not much, but slightly, because 0.6 is close to 0. Okay. Look at the kurtosis value. This is beta 2. Kurtosis value is how much? Yes, please. Anyone? What is the value of the kurtosis?
Minus
Minus
Minus 0.2.
0.2. So this is the value of beta 2. So beta 2 is negative or positive?
Negative.
Negative. Negative value means, is it platykurtic or is it leptokurtic?
Plateaukurtic.
Flat.
Yeah, platykurtic. Not plateau, platykurtic. Platykurtic means flatter. So whenever the value of the kurtosis is negative, it's flatter than the normal curve, right? So that is the meaning of this skewness and kurtosis. And the minimum value, the minimum person is of 18 years of age, maximum is of 63, and the range 63 minus 18 is 45, and these are the percentiles. See, percentage is, please mute yourself. There is some disturbance. I request to mute everyone, please. Okay. Please mute yourself. Okay. So these are the percentiles. See, there is a difference between percentage and percentile. Let me just repeat. There is a difference between percentage and percentile. So percentage doesn't give you any cutoff. It is computed out of 100%, 56%, 59%. But percentile will always give you cutoff point. That's the difference between percentage and percentile. For example, I have computed 95th percentile of the data. It says it is 53. What does this mean? It simply says that 95% of the people in your entire age group, 95% of the people, they are below or equal to the age of 53. They are below or equal to the age of 53. How many people? 95% of them. Similarly, 78th percentile is 43. What does this mean? This simply says that 78% of the people in your entire age group are below or equal to the age of 43. Right? That is the interpretation. So you must look for the interpretation very clearly. So this is very simple to interpret. So we have done analysis, this part. Now somebody may say that I want to do analysis only for male data or female data, right? Then you know how to do that. If I select only the female, then only data will be analysis will be done only for female data. Let's do that. Analysis, select cases, use the if condition, use the sex is equal to, let's say, equal to 2. So equal to sign is here 2. Sex is equal to 2 means select if sex is equal to 2 means only female data will be selected. Continue, press OK. So first of all, we have selected the female data. And wherever there is male, it is being struck off. You can see there is 1, 1. All of the entire data, it is struck off. Now, if I give any command, then analysis will be done for the female data only. Female data, how many males and females were there? 78 females. So analysis will be done only for 78 cases automatically. Let's do analysis, descriptive, frequencies. Again, age data, I'll take the same thing. Just press OK. All these parameters will be computed, but only for female because you have selected female. You can see 78 females. This is the mean age, median, but this is only the entire interpretation of the for the female. You follow my point? Yes, please.
Yes, sir.
Yes, please. Now, if I want to do analysis for male, can you repeat the steps? Let's say I want it for male. Then what to do? Anyone, please. Anyone, please.
We have to go to in the data, then select
Data, then select cases, then change this condition, change this to 1. Is that okay?
Yeah.
And press continue, press OK, and now you can see females are struck off and you are left with male. And if I give any analysis like descriptive, frequencies, everything is, once you enter, it will be retained by SPSS. All these things will be automatically computed, right? Press OK, and now this is the analysis for male, 91 male, and the entire analysis. Now, if you want simultaneously, then what to do? For male and female simultaneously, then yes, please. Anybody?
we have to split the file.
Yeah, that is one option that you can split the file. And one more here. This is what it says. Your filter is on. Can you see on the right hand side? Can you see on the right hand side? Filter is on.
Yeah.
Is it clear, visible or not?
Yes, visible.
Yeah. Now, if I remove this filter, and now your filter is off. There is no filter now. There are, let me see, data, select cases, select all the cases again, and then come back to the data. So all the cases are back again, right? All right. Now there are two options. One is you can split the file, which I have already shown you, but there is a better option, and better option is that you can explore. Explore means exploring different categories, not only male female wise analysis, but also age code wise analysis you can do. Not only gender wise analysis, because in gender wise you have to split the file, then you will split according to age code. So there will be separate analysis you have to do. But there is important explore command in SPSS. If you use that command, then both of them will be done simultaneously. First age code wise, first gender wise, and after that age code wise. How? Go to analysis, go to descriptive, and under descriptive there is option that is called explore. Explore means exploring different categories. Explore stands for exploring different categories. So click on here. It says for which variable, that is your dependent variable is age, for age variable. Now according to what? According to gender wise, factor is your gender, or age code wise. So it will do separate analysis gender wise, first male then female, and then for each age code 10 to 19, 20 to 29, 30 to 39, it will do separately. There is no need to split the file. Now it is again asking a very important question. What do you want to display? Only the statistics, only the plots, or both? Both means plots as well as statistics. So by default, this option is on. Right? So I'll simply press OK, and you will see a wonderful results in one go. Press OK, and you will see all the results. First of all, it will give you the same table, how many male and females are there. So first analysis, you can see age-wise analysis. First analysis is for male, median, variance, standard deviation, skewness, kurtosis. Once the male is over, then next analysis is for female, standard deviation, skewness, kurtosis, everything. And then this is called stem and leaf plot. This is for male, then stem and leaf plot for female. I'm just skipping this then stem and leaf plot. Then once the male and females are over, then it has drawn the box plot also. Now what is a box plot? is generally used for comparison purpose. Since we were divided into two categories, male and female, so this is the box plot for male, this is the box plot for female. Right? Now it says how this box plot is drawn. Please try to understand. There is a box in between. How this box is drawn? The lower end of this box is placed against Q1 value. Q1 stands for that 25% of the observations are below this point. Below this point. And this stands for the upper end of the box is placed against Q3. Q3 means 75% of the observations are below this point. Right? And this line stands for the median. This line stands for the median. Then this is box is drawn between Q1 and Q3 and median will be marked. If median would have been right there in the center, if median would have been there in the right there in the center of the box, then you will say there is no skewness. It is symmetrical. So with the help of box plot, you can also look into symmetrical part. But the median is not there in the center. Median is towards Q1. This is Q1. Now for any data, Q1 and Q3 can be easily computed. For any data, Q1 and Q3 can be easily computed. For example, if I give you 100 observation, then how to compute Q1 and Q3? You arrange the observation in increasing order from the lowest to the highest. Then whatever is the 25th value, that will be your Q1 and 75th value will be Q3. So let's say your 25th value is suppose 35. So you place your lower end of the box at 35. And 75th value is 40. You place upper end of the box at 40. Draw the box between this Q1 and Q3. And then from the lower end, middle part of the box, you join to the lowest value present in the data. Our lowest value was 18. So it has joined up to 18. Our highest value was 69. So it has gone up to 69. Right? Same way for female data. So male and female box comparison. Box comparison is generally helpful to compare the medians. Now if you compare median of male, median of female, they are almost same. So median values are almost same. Right? There is hardly any difference between the median age of male and median age of female. You can check from the data itself that if you look at the median of female, it is 31. Female median is 31. Let's look for the male median. Male median is also 31.
Also 31.
Yeah. So that's why there is no difference. Right? It is used for comparison purpose. So this line is called whisker. From the upper middle part of the box, it will join to the highest value present in the data. From the lower, it will go to the lowest value present in the data. And this is called a box and whisker plot. Okay. Then once gender-wise analysis is over, age code-wise analysis. 10 to 19, 4 people and so on. So first of all, the analysis of 10 to 19 years of age group. After that, 20 to 29. After that, 30 to 39, 40 to 49, 50 to 59. So entire information. And after that, it has drawn the box plot also. This is the box plot for each age group separately. And to modify any graph, let me just repeat, because today we have to go for the graphic session also. I'll draw certain graphs. To draw or to modify any graph, you have to double click that graph. So if you place your cursor, it will give you that double click to activate. So if you double click, let me just double click. So it is coming up. And it says this is called chart editor. Chart editor stands for you can edit your chart. Right? Suppose I mark here. And let's say I place my cursor here. And then right click and select this property window. This property, showed property window. So it will show you property window. And in property window, you can go for the bar options and you can increase the width of these bars so that they are clearly visible, and apply, and you can see a more width now. Then you can also, if you don't like this color, you can change the color. Let me make this color as this one. So it is, so I have selected only one. So if you select all of them together, then apply. Let me just close. Okay, just give me one moment. So it has marked now border around, you can see yellow border around all. And then let me change this to this color, fill and border, apply, and it has changed to this color, right? If you don't like this, you can change to green. So it will make this green. All right. So different colors. Then you can also make the changing of this. Let's say this is not clearly visible. So you can change from here the text style, make this bold, increase the font size, and you are getting this. Then age code. Let's say I want to write this as age category. So you can write this as proper. Let's say simply age categories. Right. And on the y-axis, here the scale is distance of 10, 20, 30. Let's say I want a distance of 5. So mark here, go to scale, and the major increment 10, I can write this as 5. You can see change as it has changed to 10 to 15 to 20 to 30. Then text style, you can write this as bold, increase the font size to 9, apply, and now you are having a very nice graph. So this is your, let's say, final graph. Now what this graph, how to read it? It's a box plot, there is a median. For example, there are only 4 observations, so there is no idea, much of the idea from here. But look at this one, 20 to 29. The median is towards Q1. If median is towards Q1, then this is negatively skewed. Here the median is towards Q1, then it is positively skewed. If median is there in the center, for example, for this age group, median is there in the center. That means if somebody asks you, is there any portion of the data which is symmetrical? Yes, you can answer that all those people who are between 40 to 49 years of age group, they are symmetrical. That data, particular data is symmetrical. This is also negatively skewed, this is also negatively skewed, this is also negatively skewed, this is positively skewed. How to check positive and negative? If the lower area of the box is less, upper area is more, then it is positively skewed. If it is opposite, upper area is less, lower area is more, then negatively skewed, right? So that is the interpretation of, and you can take this graph anywhere. Okay, so this is what the preliminary analysis is. And now let us take your exercise one by one, the assignment which I have given you, and try to do something which is given in your exercise. So I'll open up the exercise and let's try to do some of the steps. Just closing this analysis. Okay, so this is your assignment. Let's see what we have to do. See, first 2 parts you have to do. First 2 parts you have to do it yourself. You have to just look into whether it is a nominal scale, ordinal scale, or something like that. And here you have to look for the qualitative or quantitative variables, discrete, continuous type. Now let's go for the assignment. Now in assignment, I have given you this data. It is relating to some kind of scores. They are known as composite entrance scores of so how many observations are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 100 observations, right? Now what is your question? Question is enter the data into SPSS worksheet. So you will make 10 columns or you will make one column? Yes, please. What do you think? Anybody? This data is only for one variable. You will make one column or you will make 10 columns?
One column.
One column.
One column. This is just one column. So you can start, let's say 254, 182, 170, then once 132, after that you can start 200, write down one column. And above that you can give the title as endurance score. You can use underscore or you simply write score. So this is how the first A part can be done. Enter the data into SPSS worksheet. Is that okay? Yes, please.
Yes, sir.
You go to the variable view, change the name to score. That's it. Now, next part is transform the above data into natural log. How to transform the data into natural log? I have just carried out the calculations for log transformation. You know that? Yes or no? Yes, please.
Yes, sir.
So there we have computed log to the base 10. Here you have to compute log to the base E. That is also there. Let me just demonstrate how to compute log to the base 10 of this age. Let me just repeat. So how to do that? Go to transform, go to compute, go to arithmetic. This was log to the base 10. This is natural log. So click on to natural log, take it here of this age. Your will be score, and then you can give this as age, or you can write this as log age. Underscore let me use. So it will give you log value. Right? Press OK. And it has done the calculations. Now you can see just log has appeared. Log. This is what you need to do. Is that okay? Second part, you can do it now. Hello?
Yes, sir.
Okay.
Yes, sir.
Next is sort the data in ascending order. Sort the data in ascending order. Now, if I want to sort this data in ascending order, let's say sort according to male and female. So go to data. In data, there is option that is called sort cases. Can you see that? Sort cases. Hello.
Yes.
Yes, sir.
So click on to sort, and let's say I want to sort it by, say, gender. So it is asking ascending or descending. Generally we have ascending order, and if you want descending order, then female will appear first and then male. If you have ascending order, then male will come first and then male. Doesn't matter, right? So press OK, and the analysis has been done. And now you can see that first male have been sorted 1, 1, 1, and after that 2, 2, 2. Can you see that? Hello?
Yes, sir.
Yes, sir.
Yes,
So
sir.
this is what is required to be done in C part. Okay? So sort the data in ascending order. It says you have to sort the data. Data means you have to sort the score. Sort the score means you simply click on to data and then sort cases, and instead of this you have to sort age basically. Take this outside, take this outside, you have to sort age. In your case you have to sort score, ascending order. Press OK. Analysis has been done, and now it is sorting of the age. First 18, 18, then 19, 19. Is it clear that age has been sorted?
Yes, sir.
Yeah, all right. I'm taking one by one exercise so that you can complete. Now, next is compute summary statistics for the above data. This part I have already covered. That how to compute mean, median, mode, percentiles, deciles, skewness, kurtosis. I think you can do this part. Yes, please.
Yes, sir.
Yeah, good. Very good.
Through analyze part.
Yeah, through analysis you can do that. The next is make a file, temp. So this is an exercise to you. You create some Excel file, give the name as temp, right? With two variables. You have to create two variables. And what are these two variables? One is height in meter. Let's say 1.56 meter, 1.52 meter, 1.76 meter in meter. And weight. Second column you can create for weight, 62 kg, 63 kg, 76 kg, 90 kg, and so on. So you can create two columns. One column will be for height,
Another will for weight.
another will be for weight in Excel, and consisting of 20 values. So you take any 20 values for weight and height. Is that clear?
Yes, sir.
Yes, sir.
And then import that file. You give the name, one variable will be given name height, another will be weight. Save that file, and then you import that Excel file into SPSS. I have already shown you the steps. Is that okay?
Yes, sir.
Yes, sir.
Okay. And next is, once you have the data of height and weight, then it says you create another column. Column will be BMI, and in BMI you compute body mass index from height and weight. Height and weight, they are already there. Then you have to compute the BMI. Formula for BMI is weight divided by height in meter square. Weight in kg divided by height in meter square. Can you do this part or not? Yes, please.
Yes, sir.
Yes, sir.
Okay, let me just do it. Let me put some value here. Suppose your weight is 56 kg, then say 78 kg, say 90 kg. I'm just taking 2-3 values. You can take 20 values. And height in meter is, let's say, 1.78 meter. 1.78 meter, not in centimeter. 1.78 meter. What is happening? Okay. I followed. 1.78. Then suppose this is 1.67. This is 1. Say 54. This. I just enter 3 values. So I can change the name, that this is your weight and this is your height. And if you want to specify, you can write METER. METER stands for the height in meter. And if you want to specify, you can write here underscore kg. That weight is in kg. You follow my point? Yes, please.
Yes, sir.
Now what to do? You have to create another column BMI that will appear here,
Yes.
and apply the formula. Go to data. Go to transform. Go to compute variable. And in compute variable, what you need to do? Yes, please. What you need to do? Yeah. Now tell me what to do. First of all, you can give the variable name as BMI. BMI. Okay. Now,
Yes.
what should I do? Yes, please.
Then select age. Sir,
Age.
height.
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 No. What was the formula for BMI?
Weight divided by height square.
Yeah. What should I write
Yes, sir.
here? Yeah. What should I write here?
First weight.
Weight.
Yeah. So I'll take this variable here. Please do not write yourself. Otherwise, just take this variable here. Weight. Okay.
Yes.
Right.
Now after that, what it says? Divide by.
Yeah.
So this is a division sign.
Yeah.
This is a division sign. Okay. Then in division sign, you have to height square. You have to square the height.
Yes.
Height square means you have to put a bracket. Bracket, and then height in meter and square of this.
Yeah. Yeah.
Square of this means what to do. So if you want to square this quantity, you can put one more bracket and then multiply with the same quantity. Multiply with the same quantity. Remove this bracket from here. Height in meter, multiply with height in meter. It has to be multiply here. Height in meter and then multiply with height in meter. Remove this. This. I think this is what is required. Okay. So it is weight divided by height in meter into height in meter. Height into meter means height into height. Is that okay?
Yes, sir.
Yes, sir.
So it will give you BMI values, right? So just press and it will be stored here.
Sir, sorry, sir. Kindly show the height in meter. One more time, please.
Height in meter square. Okay. Weight is clear. Weight in kg. Divide this by, let's say, take this variable. Height in meter. Then multiply again with height in meter. And close the bracket. So it is weight upon height square. Is that okay? Press OK. Press OK, and the result is computed. And here are the BMI values. These are BMI values. This is how we need to compute. Is that okay?
Yes, sir.
Yes, sir.
All right. So we have done your experiment. You have done the experiment. And sometimes in experiment also they will ask you that you divide the data into 5 classes or 4 classes. Right? So if you want to do that, you can do that also. Go to transform, and under transform you go to you can go to analysis, go to descriptive, go to frequencies, and in frequency there is an option. Let's say I take age and go to statistics. So switch off all the other options. Let's say my question is, I want to make 4 classes of this. So cutoff point for 4 equal groups. Cutoff points for 4 equal groups. So you will get that. Continue. Press OK. And these are the cutoffs. So to divide the data into 4 parts, your first cutoff will be 0 to 26, then 26 to 31, then 31 to 42, and then more than 42. They will divide the data into 4 equal classes. 4 classes. Is that okay? Yes, please.
Yes, sir.
Yeah.
Yes, sir.
Okay. Now, next analysis is about graphics. So let's do some graphics. That will be the last part for today. How to plot graphics, visualization. Right? You can draw very, very attractive graphs in SPSS. Which type of graph? There is an option here. Go to graphs. बोर तो नहीं हो गए भाई? बोर नहीं हो गए? अगर बोर हो गए तो एक आधा शेर सुना देता हूं. जी, मैं क्या अगर आप बोर हो गए तो एक आधा शेर सुना देता हूं आपके लिए.
बोर तो नहीं हो रहे
नहीं सर, बोर नहीं हुआ, लेकिन सुनाना चाहे तो सुना दीजिए.
अच्छा चलिए ठीक है. वो कहते हैं ना कि मेहनत इंसान को करनी पड़ती है और मेहनत करने से डरना नहीं चाहिए. जब ये SPSS आया था, मुझे इसकी कोई नॉलेज नहीं थी, लेकिन मैंने ये सारा खुद सीखा. कहीं से कोई गाइडेंस नहीं, कुछ नहीं. मैंने SPSS को खुद सीखा. और उसके बाद आई वॉज वर्किंग विद द डॉक्टर्स फ्रॉम द हॉस्पिटल. दे यूज्ड टू कम फॉर वेरियस प्रॉब्लम्स. I solved many of the problems of the doctors, and you will not imagine, even I am talking of 2000, 2001 to 2010. At least 3-4 doctors in the afternoon, they used to stand outside my room just for consultation. I was running OPD of the doctors. Then idea struck to my mind, why not to train these doctors? Then we started holding these SPSS workshops in 2000, around 2000, and so far in India I have trained more than, I think, 50,000 people on SPSS only in India. And outside India also I have trained thousands of people in Greece, in Germany, in England, then also in US. I have been to all these places. Not only SPSS, then I learned R also. I have given a training on R, number of people. And during this pandemic period, everything was online. And during this pandemic period only, I have delivered more than 850 invited talks during 2 years' time. So you can very well imagine. तो मेरे को एक शेर याद आ गया कि सफलता इसमें नहीं है कि आप कितनी ऊंचाई पर हैं, सफलता इसमें नहीं है कि आप कितनी ऊंचाई पे हैं, सफलता इसमें है कि आपकी वजह से कितने लोगों की जिंदगी बेहतर है।
Great.
मेरी बात समझ में आई?
Yes, sir.
Yeah.
Yeah.
Okay. So we will move on to the graphics. That will be in next 15 minutes, and then I'll take up some questions. Now, one of the important point in graphics that you can draw very, very attractive graphs with SPSS. Let's start with bar diagram, simple bar diagram. Go to graphics and then go to legacy dialogues. And in legacy dialogues, there are options: bar chart, 3D bar, line, area, pie, box plot, pyramid, histogram, and all these things are here. So first of all, let's look for the bar diagram. Let's first of all draw simple bar diagram. And simple bar diagram, define. It says define. Define your, let's say, category axis is age code. Just drag and drop here. And number of cases against it will do, and you will get this plot. So this is called bar plot for age code. And if you double click here, you will come to chart editor. So this is your chart editor. You can edit your chart. If you don't like this color, right, then property window will open, fill, and you can have this color, let's say. Even you can change the color of one bar. How to change the color of one bar? Let's say I want to change, this seems to be a significant bar. Then there is an option, right click, and it says select this bar. If you select this bar will be selected, and you can change this to this color, let's say. So only color of one bar can be changed. Similarly, you can change the color of this bar. Let's say I want to make this, select this bar, and I want to make this one. So you can change the color of this, right? Similarly, as I mentioned, you can, this is 20, I can make this 5. So change the scale. Let's say I make this 5, and you will be able to see with the change of 5, you can make this bold. Change the let's say font size, preferred size, let's say 9, then bold and 9. Similarly, you can change the color, the size here. Let's say bold 9, apply, and let's say I want this to be changed. As I mentioned earlier also, let's say age categories. Age categories. Then you can add the title also. This title, you can add the title here. Let's say I give the title as bar diagram for age. Bar diagram for age. Right. So you can give any title here. Bar diagram for age. Not only this thing, but if I want to write down something here, you can also write down something. Let's say I want to write down that this is a significant bar. So there is an option, and pick up this text box. And if you pick up the text box right here, significant bar, right? Okay, and then just drag it here, and you can adjust. You can adjust accordingly. So if it is not, if you want to take it slightly here, you can take that. Doesn't matter. So you can write something in between also, right? And then instead of count, let's say my interest is to write down this as a frequency. So you can write frequency. Frequency. So count will change to frequency. And now you have a very nice diagram. You can also put the labels here. In labels, you say data labels. Okay. Go to the property window again. Property window. And okay. View elements. Show data labels. So this is show data labels. Now you can see it will show you the value also. If it is not very visible, you can change the text style. Let's say I make this bold, make this 10, so that you can clearly see that 66 is the number here, 47, and you have an option. You can make this I mean, text layout, chart size, text style, fill and border, data values. Yeah, there is an option here which is called custom. If you don't like that they should appear in the middle, you can take this to the top also. Suppose I take this to the top, so number will appear here. Now you have a nice picture, and then close. Yes, please. How this graph looks like? Yes, please. Is this
Attractive, sir. Very.
attractive? Then you can just
As informative, sir.
yeah, just copy here, and open your Word file. Open your some new Word file and paste it here. Control V. So your graph will come to the. Now you cannot do any changes here. You cannot do any changes here. But if space is less, you can adjust the space accordingly. If this is the space, you can adjust. If still space is less, you can adjust. So everything you can do. Is this okay? Yes, please.
Yes.
Yes, sir.
All right. Let's do one or two more graphs. Let's say go to graphs, go to legacy dialog, and this time let's say my interest is to look at 3D or bar diagram and cluster bar diagram. How to draw this cluster? That means your age code category wise and define clusters by gender. So it will draw side by side, one for male, one for female. Press OK and you are having this graph where the yellow, so just a minute. This green is for male, no, green is for female, and blue is for male. So you can have. Similarly, you double click and do the editing. So that is called this one, which is called bar clustered bar diagram. Similarly, you can draw the stacked bar diagram. In stacked bar, category axis is this. Drag and drop gender by this. Drag and drop, press OK, you will see that green area is covered by female and upper that area is covered by male. So that is called stacked bar diagram. Similarly, you can draw, let's say 3D picture. And 3D picture, how to draw that? It says define. Let's say I define X category as age code, Z category as gender, and number of cases in each. So you will see 3-dimensional picture. It is coming up. Yeah. So you can see all these are for female, and after that this is for male. So this is a 3D picture. Can you see that? Yes, please.
Yes, sir.
Yes, sir.
So very, very attractive graphs you can draw in SPSS. Similarly, you can draw graphs. Let's say line diagram you can draw. Simple line diagram. Let's say I take the category axis, although for line diagram you need some number of cases it will plot. So number of cases it will count and it will give you the plot. So this is a line plot. So there are 4 number of cases, 69 number of cases and so on. So that is called line diagram. Then you can draw other type of graph like area chart. Area chart means, let's say stacked area chart. Let's say category axis is age code, defined areas by gender. So very important graph side by side. So if this area is covered by female and at the top this blue area is covered by male, right? So all this you can do. Then another graph which you can do is your pie chart, which is very, very important. So define slices by age code and simple pie diagram. This is a very, very simple pie diagram. You can mold it here only. Suppose I double click, you will come to chart editor. You can enter your data values. So it will give you the percentages. That 66 is the number here, not percentages, people. 4, 4, 12, 36, 47, all the numbers are here, right? And if you want to convert this to I think there is an option somewhere. Okay. Now suppose Similarly, you can enter the option from here. You can enter the title. You can enter the pie charts, etc. So you can enter here that this is your pie chart, pie diagram. Then if you double click here again, then you can control the depth and angles also. If you want pie chart with shadow you can draw. So change this to shadow. You can see a slight shadow here. And if you want to increase the size of the shadow, let's say this one, so it will increase the size. So it is doing it. So small, big size, what happens? It has gone somewhere else. Yeah, okay. Let me draw it again. If there is some mistake, don't worry. You are likely to make mistakes, right? So do it again then. So go to analysis, go to pie diagram and define this, press OK, and you will be back here. Double click, and in double click, if you want exploded slice, you can draw the exploded slice. So this is exploded slice. And if you do not want exploded slice, then you have a complete. If you want exploded, this is separate. And if you want to show data labels, you can show the data labels. There is some problem. Okay. Then you can also draw the three-dimensional picture. How to draw the three-dimensional pie diagram? Let's say pie diagram. First of all, look at the simple again. Double click here. And then there is an option, depth and angles and 3D, three-dimensional. So it will give you three-dimensional picture. So this is a three-dimensional picture. Now your first slice is always placed at 12 o'clock. It says first slice at 12 o'clock. Suppose I want first slice at 3 o'clock. So you can change this to 3 o'clock. So it will, position will change, apply. So it has changed to 3 o'clock. If you want this to be say 9 o'clock, it will change to 9 o'clock. So you can make all type of changes, right? So these are all data values which you can show. Exploded slice you can show. So all the options are there. You have to just practice. Then one or two more graphs and then we'll stop. Box plot I have already shown. Let's say box plot for age group. So this is your box plot for age. So this is your box plot for age. So you can see this is slightly positively skewed. So this is positively skewed because lower area of the box is less. I have already explained the technicalities. So box plot. Then one of the important plot is that is called pyramid plot. Pyramid plot means side by side plot. Let's say split by gender. So you can see what is happening. Press OK. And you will be able to see that this graph is for female and this blue color is for male, side by side. And you can compare them in each age group. Right? So this type of graph is called basically the pyramid plot. Scatter plot, somebody will show you scatter plot, and finally the histogram. Histogram, let's say for age data, histogram is for continuous data along with the normal probability curve. So this is the histogram. So everything is there, right? So in SPSS, all the graphics are there, analysis you can do. So I think this is all from my side which I want to cover. If you still have some questions, I can take up during the next 10 minutes. Yes, please. Any questions?
Sir, this we have done only for one group of data.
Yeah.
In next your session, you are going to show us how to compare two group of data.
No, I think the next session will be on correlation and regression, which I am not taking. Somebody else will take, whosoever. I think tomorrow it is a correlation regression, and he or she will discuss about that bivariate data, scatter plot and all that. So they will come up, right? Okay. Then